Welcome to Land Eco Lightning Talks and Thinking Like a Landscape with Dr. Kevin McGarrigle. In this 8-part series on the natural range of variability concept in current departure, I discuss the origins of the concept, definitions and alternatives, applications, and important considerations in the implementation of the concept. In this talk, part 3 of the series, I will talk about the applications or uses of NRV. Okay, let's get started. The first application is arguably the most important, and this is quite simply to communicate the dynamic view of the system and the importance of variability to stakeholders that helps build support for management. It's been difficult, to say the least, to convince the public that ecosystem and landscapes are naturally dynamic and that variability is important to the integrity and the resiliency of the system. An NRV assessment essentially allows us to communicate this variability in a way that's easy for the public to understand. An animation such as you're seeing here conveys the essence of landscape dynamics and basically conveys the important message that variability is natural, that change within limits is good, that disturbances are a natural part of the system and drive the variability of the system, and that management can actually help, or in some cases emulate, the disturbance processes and the variability in the system. So if nothing else, NRV has application to help communicate landscape dynamics. The second application is also very important, and that is to help us understand system drivers and to help us synthesize the ecological knowledge that helps us determine the ingredients of an integral system and to better forecast future system behavior. So one of the most powerful things that NRV does for us is it forces us to synthesize what we do know and what we don't know about the system and how it behaves. It basically allows us or forces us to capture the state of knowledge about how a system works and points out what we don't know about the system and therefore can direct future research endeavors. So this is also equally important as the first application. It's simply a means of synthesizing and codifying what we know and what we don't know, and that can be very useful. The third application is providing detailed and specific desired conditions to guide project level planning. And this application is in cases where NRV is deemed an appropriate guide for management and is used to help determine what the specific, detailed, and quantitative desired conditions should be for a particular area. So in the example shown here, we have 3 developmental or several stages from early to late for some ecosystem within some landscape. And we have a natural range of variability in the percentage of the landscape in each of those several stages given by the box and whisker plot. Or alternatively, for a number of landscape configuration metrics shown in the table, we have a range of variability specified. And this information can be used to formulate detailed, specific, desired conditions. Again, assuming that the goal for an area is to restore the area to its natural range of variability. But we have to remember that NRV does not and should not dictate the desired condition of any single stand. That's the wrong scale, but rather the desired range of conditions among stands across the entire landscape. That's the right scale. The fourth application is determining the magnitude and nature of current departure and prioritizing treatments to restore NRV. So here in this application, we're not only using NRV to help quantify what those conditions were under natural conditions, what the range of variability was under natural conditions. We're using that to compare to the current landscape to see where we are most departed from those natural conditions. In this example, we're looking at, again, a several stage sequence from kind of early to late closed canopy conditions across the forest. And we're looking at the percent of the landscape in each of those several stages, where the box and whisker plots represent the natural range of variation. And the red dashed horizontal lines represent the current condition of the landscape. And where those current conditions kind of fall outside the box and whisker plots, we can effectively say the landscape is departed with regards to that condition. And we can see in this figure that the landscape is departed across all several stages. Some of the several stages are overrepresented and some are underrepresented relative to their NRV. And this information can be quite useful in helping us identify and prioritize areas on the landscape that require treatment and what kind of treatment would be necessary to move the current landscape back towards its natural range of variability. And this is an example developed for a portion of the Northern Sierras in Northern California, where we have computed the natural range of variability in a whole suite of ecological attributes and compared that to the current condition and basically developed a departure metric that says how departed each of these areas on the landscape are from their natural range of variability. In this figure, as we go from green to red, we go from relatively low to relatively high degrees of departure. And at this scale, this kind of information can be used to help prioritize areas on the landscape that might warrant developing a project for management to move the landscape back towards its NRV, should that be the goal. This is yet another example, zooming in at a finer scale, in this case, the geophysical unit scale. So these are basically terrain and climate-based units that are relatively similar in their geophysical condition. And each one of these units has a natural range of variability in a suite of ecological attributes, and that's compared to the current condition to derive a departure metric. And again, as in the previous figure, going from green to red, we are seeing increasing degrees of relative departure. And this can be useful at the local scale to identify where within, let's say, a project area, there might be opportunities for moving some of these areas back towards their NRV, should restoration of their NRV be the goal in these places. And just a note here that the land fire program, for those that are familiar with it, was initially established to quantify and map current departure. In this case, in fire regime, the fire regime condition class specifically, and it was used as the basis for prioritizing areas for treatment and, importantly, for allocation of funding. So this was one of the earlier attempts to use NRV primarily for the purposes of identifying current departure and using that departure information to help prioritize areas for treatment and to help prioritize funding allocation. But as with the previous application, it's important to remember that NRV does not and should not dictate whether individual stands are departed. That's really the wrong scale, but rather the departure of the entire landscape. That's the right scale. The last application here is providing a benchmark to evaluate the relative impacts of alternative management scenarios. So in the previous applications, we used NRV simply to quantify what the range of variability was under natural conditions in one or more ecological attributes, and potentially to compare that to the current condition. But in many applications, there may be some uncertainty in the accuracy of those NRV estimates. We're not confident that the values that we generate for the NRV in any particular ecological attribute are correct, if you will. And if that is the case, we still have an option to use NRV for scenario analysis as shown here. In this example, we have developed an NRV for this particular landscape, as shown here for a single state variable or landscape metric, the contagion metric, which is measuring the kind of clumpiness of the vegetation. And as shown in the gray bar on the lower left, we've generated a natural range of variability in the contagion metric. So the range in contagion values that we would expect under natural conditions. But we might not have confidence that the absolute values, the range from, let's say, 32 to 35 is correct, is accurate. But if that is the case, we can compare that to alternative scenarios and rely on the relative differences across scenarios to reach our overall findings. In this case, we have 8 different management scenarios represented by the different colored bars that vary in the types of treatments, the intensity of treatments, the location of the treatments, and so on. And under each of these scenarios, we can estimate what the range of variability in the contagion metric in this case would be under each of those scenarios, and compare that to the natural range of variability. And this comparison is quite useful. We can see that these 8 management scenarios differ quite dramatically in how they compare to the benchmark natural range of variability scenario. And we see a couple scenarios, and especially the MS7 scenario, the farthest right scenario in the dark blue, actually comes pretty close to overlapping the natural range of variability scenario. So once again, even if we don't have confidence in the accuracy of the NRV estimates, we can perhaps have confidence in the relative differences across scenarios. So this is probably the most reliable use of an NRV assessment, because we don't have to rely upon the accuracy of the assessment of the NRV assessment itself. We're relying upon the relative differences across scenarios. So the take-home message for today's talk is that natural range of variability has a wide variety of applications. NRV allows us to communicate landscape dynamics, perhaps the most important application. It allows us to synthesize our understanding of the ecological system. It provides detailed, specific, quantitative desired conditions to help guide management, should that be the goal. It allows us to estimate current departure, should that be of interest, and potentially to serve as a benchmark for alternative scenario analysis. So a wide range of applications of NRV. Well, this is Dr. Kevin McGarrigle signing off from this episode of Land Eco Lightning Talks. I hope this talk has been helpful, and I hope you join me for my next lightning talk. In the meantime, keep on thinking like a landscape.